For years, adding a standard tool like an observability platform or a custom email router to a codebase meant hitting a massive friction point. A developer had to stop coding, pull up hundreds of pages of documentation, and mentally map out the entire integration before writing a single line of logic. Today, developers expect to bypass that process entirely. The modern expectation is you hand a codebase to an autonomous AI agent, tell it what to connect, and let the model navigate automatically. But relying purely on an agent's base knowledge introduces a severe vulnerability. Large language models generate outputs based on their pre-training data, which is static. Software APIs, however, evolve constantly. Interfaces change and old methods are deprecated, meaning the AI is operating on a memory of the web that is already out of date. This flowchart illustrates the exact error loop this creates. The agent confidently hallucinates a deprecated method from its stale data, writes broken instrumentation, and only realizes its failure when the test fails. It then slowly crawls the live documentation to correct its mistake. Pure autonomy is incredible for open-ended, creative tasks, but when it comes to precise, domain-specific engineering, giving an agent unlimited freedom means giving it the freedom to make assumptions. Raw intelligence cannot overcome outdated knowledge. To stop an AI from writing broken code, they have to restrict its autonomy using a structured algorithmic manual. In AI engineering, this is known as a skill. Curious. Think of an AI skill like the instruction manual for a Rubik's Cube. An autonomous agent has the capability to twist and turn the cube in any direction, but without guidance, it's just making chaotic moves. A skill provides a formalized shortcut, a reliable, step-by-step workflow that bridges the gap between strict rules and the agent's broad capabilities. The team at Langfuse, an open-source observability platform, ran into this exact problem. They wanted to build a custom skill to help users install Langfuse into new projects. But to write a useful manual for an AI, they first had to identify exactly how agents were misinterpreting information in the wild. This decision tree represents what developers call a trace. Tracing is how engineers solve agent unpredictability. Instead of just looking at the final code, tracing allows developers to monitor the exact execution paths, internal logic, and specific data calls. In real time, tracing revealed massive blind spots. For instance, agents would confidently hallucinate non-existent command line parameters associated with the word trace. Or they would casually assume the user's default data region was in Europe, ignoring US options entirely. Fixing these errors required structural changes. Instead of letting the agent wander the web, the team provided explicit agent sitemaps. They also forced the documentation to render in clean Markdown rather than raw HTML. Otherwise, the coding agents would try to parse the entire website's code, wasting precious computational tokens on layout tags. Developers cannot assume an AI will navigate information like a human browsing a wiki. They have to build dedicated, machine-readable infrastructure, specifically designed to guide the agent's attention. This split-screen comparison shows how that infrastructure speeds things up. On the left, an agent linearly reads 5 entire pages of documentation to find one parameter. On the right, it uses a dedicated search endpoint, known as RAG, to fire off a single instant query and pull back exactly the relevant paragraph. Search endpoints offer a massive secondary benefit, visibility. By tracking the specific natural language queries the agents make to the database, developers can map exactly where the AI gets confused, revealing unexpected edge cases and gaps in their own documentation. Once the agent retrieves the right information, its output still needs to be verified. This requires a basic evaluation setup built right into the workflow, using simple natural language checks and LLMs as a judge to confirm the agent actually wrote the correct code before it deploys anything. It's tempting to hard code all this documentation directly into the skill's initial prompt so the agent has it immediately. But if that text isn't constantly updated, the skill decays. A reliable skill must always point outward, referencing live external documentation to survive software updates. An AI skill is only as effective as the real-time data it connects to and the immediate quality control mechanisms that judge its work. With the skill functioning, the Langfuse team tried an experiment in auto research. They pointed an agent at its own skill and ask the AI to suggest improvements to optimize its own execution. To do this, you have to define a target function, the specific metric you want the AI to maximize. The metric developers choose here will dictate the agent's entire behavioral pattern. This timeline illustrates how optimization can fail. When instructed to complete the task in the fewest possible turns, optimizing purely for speed, the AI realized reading documentation took time, so it deleted the steps required to fetch the manual. By relying on internal memory, the AI increased its speed in the short term. But by lobotomizing its ability to fetch up-to-date context, it guaranteed that within 3 months, its code would be entirely obsolete, ensuring long-term failure. Optimizing an autonomous agent for a single metric without rigid safety constraints will inevitably cause the system to dismantle its own reliability. We are rapidly approaching a state where developers will simply connect a repository to a service, and an orchestration agent will auto-regressively manage the entire process, from setup to fetching context to final evaluation, all on its own. To keep these systems accurate, future skills will likely manage the caching problem by utilizing time-stamped data. If an agent recognizes that its instructions are older than a specific date, the system will automatically alert the AI to fetch a fresh update before it writes a single line of code. The frontier of AI engineering relies less on the raw, open-ended intelligence of the base model. True reliability comes entirely from the surrounding infrastructure, the traces, the dynamic documents, and the structured skills that tether the AI to reality. If you want to explore more about building reliable AI workflows, check out the Learn by Doing with Stephen YouTube channel and dive deeper into the technical details on the Stephen Data Talk podcast.